All right, we're looking at Module 8 here today. We've got the graphs and features, and we're going to look at three things in this module. This is day 1, so our success criteria will be able to identify domains and ranges from a graph and an equation. So that's what we're going to look at to start with, is domains and ranges of a graph and equation. So we'll talk about how to communicate that and what that looks like as well. So, all right, so let's start here. When we talk about a domain of a graph, that is really the set of all x values. So the set of x values that a graph has. Okay, you can think of this as actually the input if you want to think of it as a function. So when we talk about a function like f of x, right? If we have f of x equals like some value like 3x squared, well, my input for x, that's what number I can actually input. And you might say, well, what do you mean by that? Like, can't you put any value in? For this function, you can, but sometimes like you can't have every single value. So for example, like you can't divide by 0, right? So if there's an x in the denominator, like you're going to have to exclude that x value as an input value, okay? Your range is going to be the set of y values. And again, this will most likely be your output. So it's the number you get out by plugging this in, okay? Again, so if I decide to plug in 1 for this, right, that'd be 3 times 1 squared. That's my input. And what I get from it is 1 squared is 1 times 3. I get 3. That would be my output value. Okay? All right, so we want to know what numbers can we input and what values will I get out from those inputs. So what values are the possible values that I can put in without getting a error or something that causes problems, okay? We're going to communicate this with what we call interval notation. So if the domain and range is represented by an interval of real values, we'll use interval notation, okay? If it's not, then we're going to use what we call set notation, okay? So let's talk about this. So for example, if I have parentheses, so this right here, parentheses -2, comma 6 with this bracket, this is the interval from -2 to 6, not including -2. So the parentheses does not include, the bracket does include. So this actually is a really good guide right here. Parentheses is not included, bracket means included. Okay? So if I have bracket 5, comma 12, parentheses, this is the interval from 5 to 12, not including 12. Okay? All right. So that's great if I have like this set of values that doesn't stop. So like these straight lines that you guys can see down here, that's awesome for that. Okay? But if I have a bunch of ordered pairs, for example, right here, if I have just these XY points, so this is a bunch of XY points that I have here. Like, how do I write the domain and the range for that? Here's how we do this. We're going to write all the X values out just in a line. So 1, 2, 4, and 5. And you can put it in numerical order. That's a good habit. And then we're going to put these little squiggly brackets, or I believe they're called braces, around them. Okay? And this would be my domain. I would just write it out. That's going to be different than this graph down here where it's at everything. It's a continuous with lines, and there's all these dots, everything in between, like 1.5 and 1.4 and 1.7, okay? And then my range, I'm just going to list out all my y's. Again, you can do it in numerical order if you want to. So that should be 3 and 6 and 7. I do not need to write 3 twice if it repeats. I'm just simply communicating what y values it has, okay? And then I put those squiggly brackets. This is what we call set notation. Okay? So I have interval notation up here and set notation. Okay? If I look at, so that's how I would do something that doesn't have like a continuous values or an interval. So I have interval notation and set notation. Most of the time you guys are going to use interval notation. Okay? So let's just look at some examples here. Okay, so this one I'm going to use lines. Here I have my line, and my domain is, remember, my x values. So everything, I'm just going to look at how far left it goes on the x-axis to how far right it goes. So it goes from 1 to 4, and then I have an open dot and closed dot, so we need to talk about that. Open dot is not included. Closed in dot is included. Okay, so my domain would be 1, 4, and I want an interval for this. I'm going to use a parentheses here and a bracket there. So this is the interval from 1 to 4. All numbers from 1 to 4, but we're not including 1. Okay? All right, then my range, for my range, I'm going to go my y values. So here's my y-axis. That's the furthest down it goes, and I always go least to greatest. There's the furthest up it goes. So that would be from 1 to 7, but I'm not going to include 1 in there. So I use brackets on the 7 and parentheses on the 1. Okay? This would be how you'd write this. This is what I expect you to be able to do, is be able to write these intervals out. Okay, for my domain on this second one here, so again, I look at the farthest left it goes, which is this dot right here, and the furthest right it goes is that dot. So everything in between. So that would be from -2 to 2. And I'm going to put parentheses here and brackets here because open dot is not included. Okay, and then the farthest down this goes are these 2 points, which is at -5, and the furthest up, it does get to this point right here, so it goes down to up. So that'd be from -5 and then to 4. And I am going to bracket this because it doesn't have an open dot, so it gets all the way there. It's including that. And then here at 4, I have an open dot and a closed dot. The closed dot is including it, so it's just over here, not on the left side. So it'd be from -4 to 4 with brackets on both sides of those. Okay? All right. This next example here, this is a table of values, which is the exact same thing as just writing out your points. So it's not the numbers in between. We just have this ordered pair 0, 3, and this ordered pair at 2, 11. It's just in a table instead. So all I'm going to do is just list out my values that are my x for my domain and put these little squigglies around it, okay? And then for the range, I'm just going to list out these others. So 3, 11, 19, 27, and 35. And again, I'm going to put the squiggly brackets around. So this would be how I'd write this one because these are set notation, interval notation. Okay, let's talk about domain restrictions from an equation. So those are from graphs and stuff. Let's talk about from an equation. Really, there are two things that have domain restrictions up to this point. There's a few others that you guys will get into. But right now, anytime I have a fraction, or what we call a rational, or this is a rational, meaning I have an x in the denominator, that is a restriction. Okay, so there's problems with that. I don't have every x value from left to right. And anytime that I have a square root as well, I'm going to have a restriction as well. So there's going to be restrictions on any of those two. Everything else, the domain goes all the way to the left and all the way to the right. So if I look at this one, x squared plus 7, let's just go back to our Desmos here. And I go plus 7 here. Oops. This graph is moving left forever and right forever. So it has these arrows that are on it. It's just, again, it's just moving forever. Again, if we keep zooming out, it's just going to keep on moving left and right for forever, okay? So anytime that you do not have a rational or square root, I just want to know the domain of this. This is going to be left forever and right forever. And how I write that in interval notation would be negative infinity would be left forever, and positive infinity would be right forever. And I have to use parentheses on this because infinity is just an idea, not a number, so I can't get to infinity, okay? So this is how it is for every single other equation. So, for example, if I had f of x equals x to the third, my domain for that would be from negative infinity to infinity, okay? Same thing if I had, let's say I had f of x equals, let's say, the absolute value of x. Well, what's the domain? Domain is going to be negative infinity to infinity because there is no restriction or problems with plugging x values in. And remember, x is what I'm plugging in for that, okay? All right, let's talk about the two that do have restrictions. So for fractions, I just can't divide by 0. So I can't put an x in here that'll make me equal to 0. So essentially, my domain restriction is whatever makes this equal to 0 because it can't. So if I add 4 over and add 4 over, that means x cannot equal 4. That's my domain. How I write that is it's literally everything but 4. So that would be from negative infinity to 4. Again, everything but 4. And then 4 to infinity. So I'm going from negative infinity to infinity with these parentheses to not include 4. It's everything up to 4. So like 3.9 and 4.1, those are all in this interval. And then I use this little union sign. So it's both these intervals. I got to do both like that. Okay, so really all you're going to do is just look at the denominator and figure out what makes it equal to 0 by solving it. Okay? That's how you would go about that one. The square root one, you would take what's under the root, so x minus 7, and it has to be greater than or equal to 0. So I would just solve this for x, so add 7, and this would be x has to be greater than or equal to 7. So how do I write that? That's from 7 to infinity, because greater than 7 is that direction, so it would be 7 to infinity, and this will be a bracket because of the equal sign. So you just take what's underneath the root, put it greater than or equal to 0, solve it, and that'll tell you what the domain is. Okay? For the rationals, take what's underneath, it cannot equal 0, find out what that is, and then you just go from negative infinity to that number, and that number to infinity. And that's how that works every single time. And then anything that's not those two is just from negative infinity to positive infinity. All right, that's it. We'll see you.